Okay, chapter 10 here. We're going to talk about statistics. And we'll start in section 10.1 and discuss frequency distributions. So let's say I take two dice, like these two dice, and I roll them. Well, when I roll two dice, I can get a certain number of results, certain number of finite results. I could roll a 1 and a 1 and get a 2. I could roll maybe a 1 and a 2 and get a 3. Maybe a 3 and a 1 or a 2 and a 2 and get a 4. I could get a 5. I could roll a 6 if I sum the total like is shown here on these two dice with 4 plus 2 is 6. I could roll a 7, an 8, a 9, 10, and scroll down a little, an 11, or 12. So those are the numbers, potential numbers I can roll if I take two dice and I roll them and I sum the number on the top face. Well, say I roll them once and I end up with a 3. And then I roll again and I get a 7. Maybe I roll again and I get a 7 again. And perhaps I roll again and I get a 5. So what I'm doing here is I'm keeping a tally of my rolls. I roll, I get a 6 and a 4 maybe, and it's a 10. And I roll these things 50 times. I roll the dice 50 times, and I get 50 different results. So I roll the dice a total of 50 times, and my marks here show my tally. Well, if I add each of these tallies up, I can actually get a frequency that they occur, that each of these numbers occur, the frequency that each of these results occur. For example, 2 only occurred 1 time, 3 occurred 3 times, 4 occurred 5 times, 5 occurred 2 times, 6 occurred 9 times, 7 8 times, 8 6 times, not 7, 9 occurred 6 times, 10 4, 11 5, and 12 just once. If I add all these up, I said I was doing it 50 times, then there's a total of 50 here. So we call this a frequency distribution. So we call that because it's a distribution of the frequencies that each occurrence occurs. Frequency distribution. So it's a number of times that each outcome occurs. Each possible different outcome occurs. Okay? So that's how you might set up a frequency distribution concerning a situation. Well, we can extend this a little bit, and this is not talked about in your book, but we can talk about a relative. Let's actually write it out. A relative frequency and that's just the frequency related to the number of rolls. So what I would do is I would take, for the first one, I'd take 1, and I'm going to divide it by the number of rolls, 50. So it gives me a decimal or a percent, 0.02 for 1 over 50, which is the same thing as saying 2%. But so then this is 3 over 50. and that's 0.06, and then 5 over 50, 10% equals 0.1, so on and so forth. I'll just write these down. 2 over 50 is 0.04 for our relative frequency. 9 over 50 is 0.18 approximately. 8 is 0.16. 6 is 0.12. 0.12 again. 4 we did already. 0.08. Actually, we didn't do 4, but now we did. 5, 0.1, and 1 is 0.02. If I were to take and add up all these decimals in this relative frequency, you would find that this equals 1.0. Because there would be a total of 50 in the numerator divided by 50, so it's 1 over 1, it'd be equal to 1. So that's what a relative frequency distribution looks like. And this is a frequency distribution. Now, just looking at these, it's not easy to, I'll put this down, relative frequency distribution. It's not easy to just look at these values here in this table. You could look at them and you can get some information, but there's better ways to present this information so that we can see at a glance what is really going on. And what we can do is we can graph or plot frequency distributions. And we can do these in a number of different ways. We could use a Cartesian axis system. Why is that upside down? So I could take on a Cartesian axis that I set up here, where the x-axis is the number I rolled and the y-axis is the number of times I rolled that number. Then I can start setting up a plot of this. So I rolled 2 once, so that's 1 here. I rolled 3, I think 3 times. I'm going to try to do this from memory. 4, I think I rolled 5 times. 4. So let's take a peek. 1, 3, 5. Yeah, there we go. I rolled 5 2 times. I rolled 6. The most, I think I rolled 6, 7 times. So here I've filled in all the points associated with the number of times I rolled. So already this picture shows us a little bit about what's going on. Here towards 6 and 7, it seems like right off the bat these things jump out as relatively a lot higher than the other numbers. Now I can create what I call a bar plot. So this is kind of like a dot plot. What I'm going to create is a bar plot. Let me do that. Okay, so here I've set up a bar plot, and in a bar plot I'm going to go and I'm going to make bars, little rectangles that are the height of what my frequency is, and let's just say they're a width of a unit distance here, but I start at 1, half down, or 1.5 here, and go to 2.5, then 2.5 to 3.5, so on and so forth. And I make these rectangles. I could color them in hash marks, so maybe they stand out more. And now with a bar plot, you can see that at a glance, I even get a bigger understanding of what's going on with my information, with my data. So bar plot's one type of plot. So I have a bar plot. Over here, this axis, this y-axis, was the frequency in the actual number. I can set up a relative frequency based on my relative frequencies that I had over on this side here. And you see if I fill in the information on this vertical scale here, I go 0.2, 0.4, 0.6, 0.8, and 1 as a relative frequency. And the reason I wanted to do that is because I want to show you a different type of plot called a pie chart. And pie charts look a lot better if you use relative frequencies with them. So I'm going to use relative frequencies and put those, I'm going to use the relative frequencies associated with this data and put this in a pie chart. So here I've started drawing a pie chart. I'm putting in the most frequent number, which was actually a 6, that not a 9 but a 6, which I rolled 18% of the time. Now I've added 7. I rolled 7 about 16% of the time. Both of these together make up 34%, which is almost a third, well, a little over a third of the pie. And then I rolled 8 12% of the time. So all total, this is over 50% of the numbers I rolled were just these 3 numbers. And then I'll sketch in the rest of this. And then here I filled in this pie chart with the rest of these. Rolled 9 12% of the time. It takes up 12% of the pie, kind of like a pizza, 12% of the pizza. 11 and 4 each take up 10% each. 10 is 8%, 3 is 6%, 5 is 4%, and then 12 and 2 are 2% each. And sometimes when you do these, it might be easier to do something like this in a program, like for example Excel. So let me slap up an Excel picture. And then here's an image of the above of a pie chart created with that 2 dice data. So the brown is associated with rolling the 6, and then this black and this red are the 7, 8, and then 9 is here, and so on and so forth. And this is colored. And so this at a glance lets you see relatively how much larger the chance is of rolling this certain numbers when you roll 2 dice. So I think I'll stop there.